Hi guys, in this video I'm going to show you how the formula for the internal division of a line was derived. And also we are going to emphasize on a special case of the internal division, which is the midpoint of a line, where the point divides the line equally into two parts. After that, we are going to solve some examples to see how these formulas are used. There is also a case whereby a point divides a line externally, but our main focus in this particular video will be on the internal division. But I will talk a little on the external division at the end of this video. And I will also drop a link for the video that will concentrate solely on the external divisions. Now we are over with the introductions, let's start driving some formulas. In the Cartesian coordinate plane, we have a line AB, and the coordinates of line A is x1, y1, while the coordinates of line B is x2, y2. If we plot a point P on the line, and let the coordinate of P be x, y, we can see that the point P has divided this line internally into two parts, AP and PB. Let's say the ratio of the length of line AP to the length of line PB is equal to the ratio of L:M. That is, if the length of line PB is 6, while the length of line AB is 6, while the length of line PB is 3. Then, since the ratio of 6 is to 3 is equal to 2 is to 1, therefore L is equal to 2 and M is equal to 1. Since the ratio of line AP to line PB is equal to L:M, therefore the point P has divided line AB in the ratio of L:M. So we need to drive a formula for calculating the x and y coordinates of P. We may already know that the x coordinate of P is equal to Lx2 plus Mx1 all over L plus M, and the y coordinate of P is equal to Ly2 plus My1 all over L plus M. This is the aim of this video. We are going to show why x is equal to Lx2 plus Mx1 and why y is equal to Ly2 plus My1 all over L plus M. To prove this, first we are going to plot our coordinates in their respective axes. Since this point is x1, y1, therefore here will be x1 and here will be y1. Since this point is x, y, here will be x and here will be y. And since this point is x2, y2, therefore here will be x2 and here will be y2. So we need to project A horizontally to the right and B vertically downwards till they meet and form a triangle. We will also project point P downwards till it touches the projection of A, and let's call this point C. And we'll also project P towards the right till it touches the projection of B, and let's call this point D. We can see that this angle and this angle are equal since they are complementary angles. Likewise, this angle is the same as this angle because they are also complementary, and the angle here is 90 and the angle here is 90. Since the angles in triangle APC is the same as the angles in triangle PBD, therefore APC and PBD are similar triangles. Since these two triangles are similar, therefore AC divided by AP is the same as PD divided by PB. So we write that AC, the line AC divided by the length of line AP is equal to the length of line PD divided by the length of line PB. If we multiply both sides by line AP, we get that the length of line AC is equal to PD all over PB times AP. Since the ratio of AP to PB is equal to L is to M, therefore the line AP divided by the line PB is equal to L over M. So here we can say that the length of line AC is equal to PD all over M times L. We replaced AP over PB with L over M. If we divide both sides by L, we have that the length of line AC all over L is equal to length of line PD all over M. The length of line AC is the same as the distance from x1 to x. And to find the distance from x1 to x, we take the absolute value of x1 minus x. Therefore, the length of line AC is equal to the absolute value of x1 minus x. And to find the length of line PD, this is the same as the length of x to x2. And to find the length of x to x2, take the absolute value of x minus x2. So we have the length of line PD to be the absolute value of x minus x2. So if we substitute this for this and this for this, we have that the absolute value of x minus x1 all over L is equal to the absolute value of we have that x1 minus the absolute value of x1 minus x all over L is equal to the absolute value of x minus x2 all over M. Now we need to get rid of this absolute value, and in the property of the absolute value function, the absolute value of a minus b is equal to a minus b if a is greater than b, or minus a minus b if a is less than b. So here there are two cases. It's either that x1 is less than x, which will be less than x2, or x1 is greater than x, which is greater than x2. These are the two possible cases so far x is in between x1 and x2, because x divides line AB internally, so x should be in the middle of x1 and x2. So in our first case, if x1 is less than x and x is less than x2, therefore the absolute value of x1 minus x2 will be equal to minus x1 minus x, and the absolute value of x minus x2 will be equal to minus x minus x2. We now have that minus x1 minus x all over L is equal to minus x minus x2 all over M. From this we got this, so we can multiply both sides by minus 1. Multiply both sides by minus 1, so we have that x1 minus x all over L is equal to x minus x2 all over M. For the second case, case 2, if x1 is greater than x and x is greater than x2, therefore since x1 is greater than x, the absolute value of x1 minus x is x1 minus x, and since x is greater than x2, the absolute value of x minus x2 is x minus x2. So we now have that, so this will now give us that x1 minus x all over L is equal to x minus x2 all over M, because x1 is greater than x and x is greater than x2. So the absolute value of x1 minus x all over L equals the absolute value of x minus x2 over M, give rise to this, since x1 is greater than x and x is greater than x2. So you can see in these two cases, in the two possible cases we have, x1 minus x all over L is equal to x minus x2 all over m. In the two possible cases, we all have that x1 minus x all over L is equal to x minus x2 all over m. So now we cross multiply and we'll have that mx1 minus mx is equal to lx minus lx2. So if you collect like terms here, we have that lx2, we move mx to the left and move lx2 to the right. We have that lx2 plus mx1 is equal to lx plus mx. So factorize x here. We now have that lx2 plus mx1 is equal to L plus m times x. So if we divide both sides by L plus m, we will now have that x is equal to lx2 plus mx1 all over L plus m. And this is how we got the formula for calculating the x value of p. Now let's derive that of y. While deriving that of x, since triangle APC and triangle PBD are similar, we say that line AC divided by line AP is equal to line PD divided by line PB. But to derive that of y, we are going to use line PC divided by line AP is equal to line PD divided by line PB. So we are going to write that line PC divided by line AP is equal to line PD divided by line PB. Since these two triangles are similar, we can say that this is true. So if you multiply both sides by AP, we have that line PC is equal to PD divided by PB times line AP. And like we did for x, since AP over PB is equal to L is to L over M, we are going to replace it. So we have that line PC is equal to line PD divided by M times L. If we divide L from both sides, we have that PC all over L is equal to PD all over M. The length of line PC is the same as the distance from y to y1. And to calculate the distance from y to y1, we take the absolute value of y minus y1. And to calculate the length of line PD, we have to take the absolute value of y minus y2 minus y. So the length of line PC is equal to the absolute value of y minus y1, and the length of line PD is the absolute value of y2 minus y. So we are going to substitute this for this. We are going to substitute PC for this and PD for this, and we have that the absolute value of y minus y1 all over L is equal to absolute value of y2 minus y all over m. Now we want to get rid of this absolute value, and there are two cases here. It's either that y2 is greater than y, which will be greater than y1, or y2 is less than y, which will be less than y1. Here y1 is less than y, and y is less than y2. But if y2 were to be under, we'll have that y2 is less than y, which will be less than y1. So these are the two possible cases. So now we all know that the absolute value in the property of the absolute value of a minus b is equal to a minus b if a is greater than b, or minus a minus b if a is less than b. So in the first case 1, we have that y2 is greater than y1 is greater than y, which will be greater than y1. So remember, we want to convert that y minus y1 all over L. We want to remove the absolute value from y minus y1 all over L equals y2 minus y all over m. We want to get rid of this absolute value here. Since y is greater than y1, in our first case, we are using if y2 is greater than y1. So here we have that y is greater than y1. So if y is greater than y1, therefore the absolute value of y minus y1 will be y minus y1, and the absolute value of y2 minus y, since y is greater than y, the absolute value of y2 minus y will be y2 minus y. So in our first case, we have that y minus y1 all over L is equal to y2 minus y all over m. And in our second case, if y2 is less than y and y is less than y1, considering this second case, this is going to give us minus y minus y1 all over L is equal to minus y2 minus y all over m. So if you multiply both sides by minus 1, we have that y minus y1 all over L is equal to y2 minus y all over m. So we can see that in these two cases, the absolute value of y minus y1 all over L equals y2 minus y all over m gave rise to y minus y1 all over L equals y2 minus y over m, considering the both cases. So we can write here that from this, we now get that y minus y1 all over L is equal to y2 minus y all over m. We can cross multiply, and when we cross multiply, we have that my minus my1 is equal to ly2 minus ly. We are going to move ly to the left hand side and my1 to the right hand side, and when we do that, we have that ly plus my is equal to ly2 plus my1. We are going to, if you factorize y, we have that y into L plus m is equal to ly2 plus my1. So we can divide both sides by L, and we'll have that y is equal to ly2 plus my1 all over L plus m. And as you can see, we derived the formula for calculating the y value of P, the y coordinate of P. So we can say that if P divides line AB internally by the ratio of L is to m, and the coordinates of A and B are x1, y1 and x2, y2 respectively, then the coordinate of P, x, y, to find their coordinate, this will be equal to lx2 plus mx1 all over L plus m, ly2 plus my1 all over L plus m. So this is the formula for the internal divisions of a line. We have successfully driven the formula for the internal divisions of a line. Some of you may not know how to use this formula, but there is no problem because we are going to solve some examples with this formula to see how it is used. But before then, we are going to look at a special case for the internal division of a line, where P divides the line into two equal parts. Therefore, the point P is in the middle of line AB, and P is said to be the midpoint of line AB. The midpoint of a line. In this case, point P divides line AB in two equal parts. So the length of line AB is equal to the length of line PB. The length of line AP is equal to the length of line PB. So we can say that L is equal to M. And since P divides line AB internally, therefore the x coordinate of P is lx2 plus mx1 all over L plus M. And the y coordinate of P is equal to ly2 plus my1 all over L plus M. And since L is equal to M, we can substitute L for M in both equations, and we have that x is equal to mx2 plus mx1 all over m plus m, and y is equal to my2 plus my1 all over m plus m. Therefore x is equal to m into x2 plus x1 all over 2m, and y is equal to m into y2 plus y1 all over 2m. If you divide m in both the numerator and denominator in both equations, we have that x is equal to x2 plus x1 all over 2. We have that x is equal to x2 plus x1 all over 2, and y is equal to y2 plus y1 all over 2. Therefore, if P divides line AB into two equal parts, P is said to be the midpoint of line AB, and the x and y coordinate of P is given by x1 plus x2 all over 2, comma y1 plus y2 all over 2. Now let's solve some examples and see how these formulas are used. Example 1. Find the coordinates of the point that divides line AB in the ratio of 1:2. If the coordinate of A is 5, -2 and the coordinate of B is 6, 3. We are going to plot these points in the Cartesian coordinate plane. And let's call the point that divides this line P. We will call the coordinates of A x1, y1, while the coordinates of B x2, y2. And since P divides line AB in the ratio of 1:2, therefore L is equal to 1 and M is equal to 2. From our derived formula, the x-coordinate of P is equal to Lx2 plus mx1 all over L plus M. If we substitute our values into the formula, we have that x is equal to 1 times 6 plus 2 times 5 all over 1 plus 2. Therefore, x is equal to 6 plus 10 all over 3, which is equal to 16 all over 3. And the y-coordinate of P is equal to ly2 plus my1 all over L plus M. So we have that 1 times -3 plus 2 times 2 all over 1 plus 2. So this equals -3 plus 4 all over 3, which is equal to -1 all over 3. Therefore, we have the coordinates of P to be 16 all over 3, -1 all over 3. Example 2. Find the midpoint of line AB if the coordinates of A is -2, 0 and B is 6, 4. To visualize these points, we are going to plot them in the Cartesian coordinate plane. Let's call the coordinates of A x1, y1, while the coordinates of B x2, y2. And let M be the midpoint of the line. Therefore, M should be located at the middle of line AB. From our formula, the x-coordinate of M should be equal to x1 plus x2 all over 2. So, substituting, we have that x is equal to -2 plus 6 all over 2, which is equal to 4 over 2, which is equal to 2. And y is equal to y1 plus y2 all over 2, which will be equal to 0 plus 4 all over 2, which is equal to 4 over 2, which is equal to 2. So we have the x and y coordinate of M to be 2 over 2. So M is located at coordinate 2, 2. I promise that at the end of this video, I will explain how a point can divide a line externally. So if you have a line AB, and if you project line AB outwards in a straight line to a point P, if the ratio of line AP to line PB is L:M, and the coordinate of A is x1, y1, while the coordinate of B to A is x2, y2. So to find the coordinate of P, which is x, y, and the coordinate of P will be gotten by Lx2 minus mx1 all over L minus m, Ly2 minus my1 all over L minus m. To learn how to derive the formula for the external division, you can click here. And please leave a like if you understood this video, subscribe to my channel for more math videos, and if there is any part of this video that isn't clear enough, you can reach me in the comments and I'll get back to you. Thanks and have a nice day.